Today we are actually going to graph the exponential growth and decay functions, and we're going to go through a couple of these together and then talk about domain, range, and asymptote for all of them, and that should give you what you need. Normally in class we would do the graphing calculators, but since you're at home, I would suggest www.desmos.com. I will show you how to use this. It's actually fairly simple to use this for graphing exponential growth and decay. So the first one we're going to graph is y equals 3 times 2 raised to the x plus 1 minus 4. Now the first thing that you should do is think about up and down movement, and this is something you might want to add to your note card. The first thing you do is vertical movement. The vertical movement has a huge effect on the graph, the asymptote, and the range. So this particular one has a minus 4. That indicates that this graph is going to move down 4. So instead of the asymptote being on the x-axis, that asymptote is going to move down 4. So 1, 2, 3, 4. I'm going to put a dashed line at -4 and write down that my asymptote is y equals -4. That's going to help us when we actually go to graph. Now I'm going to go to Desmos. When you type in www.desmos.com, it takes you here. Click on Graphing Calculator. Technically, you can use this little, not that keypad, this keypad to type in your function. So y equals, but see it's weird for me. I just use my keyboard, honestly, to type it in. So y equals 3 times, you can use your little asterisk for the times, or you can use parentheses for times. 2 raised. I want to do x plus 1, but when I type in x plus 1, do you see how it doesn't put the plus 1 in the exponent? So to get around that, we're going to put our exponent in parentheses, and I'm going to do x plus 1 in parentheses. That keeps that plus 1 up in the exponent where it's supposed to be, and then type in minus 4. So here's the graph, and you notice in this picture that asymptote, that line that the graph is approaching, is y equals -4. So you can see that in this picture, but once we put points on our graph, it's not going to be quite as easy to do. Now we want some actual points that we can put on our graph. We don't just want to estimate. In Desmos, if you click this little, what looks like a settings wheel, it says Edit List. And then click the thing that looks like a table, it says Convert to Table. It will give you a list of points. And sometimes they're nice looking points, sometimes they're not nice looking points. But this is what you would record in your table so that you could graph some of these points. And I'm not going to record 220 because I know that's off my graph. I'm not going to use that at all. So I'm going to use -2, -2.5, -1, -1, 0, 2, and 1, 8. So when I go back here, I'm going to write in those numbers that I found from Desmos. And plot those points. -2, -2.5 is there. -1, -1, 0, 2, and 1, 2, 3, 4, 5, 6, 7, 8. That one's even off my graph. I didn't realize I used such tiny graphs on this. This shape, it curves up through these points, and you can look back at Desmos to help you with the bottom part of the graph. This is going to curl closer and closer to that asymptote, but it's not going to touch it. If your pencil lead appears to touch it, that's fine, but the important thing is that you cannot cross it. So if you're drawing this down and you cross that asymptote, that would be bad, and that would make you lose points on whatever assessment you were looking at. So there's our graph. The domain is the easy part. Domain is all real numbers. Your range is tied to your asymptote. For your range, I want you to think about, was there a flip or no flip? A flip happens if there's a negative in front of the number before the thing that's raised to the exponent. So this one has no flip. If there's no flip, it's going to be y is greater than whatever your asymptote value is. So our range is y is greater than -4. Now I want to show you something like this example, how to type this into Desmos. So I'm going to go back to Desmos. And you can click this X to take out whatever was in there before. I want y equals -2. Oops, it would help if I clicked here. Y equals -2, parentheses, 1/2. For 1/2, you just do 1 divided by 2, and it creates that for you. You can move outside of the parentheses, raised to the x. If we needed to do x plus 2 or x minus 5, you would want to put that x in parentheses. You'd want to do that so that you could add more things in there, but we don't have anything on this one, so it's fine. And then plus 1. There's our graph. The picture shows you that there was a flip, but the negative in front of that 2 also tells you that there was a flip. So that's just how you type it in. Now, if we go back to our notes, I just want to talk through domain, range, and asymptote. Domain, that's the easy part. I would always do your asymptote before you do your range. Our asymptote comes from this number, so this helps us find our asymptote. It says +1, so our asymptote is y equals 1. You also want to take into account whether there's a flip or not. This one does have a flip, which means your range is going to be y is less than whatever your asymptote is. So on all of these, you can do this part without going to Desmos. You can do this part first, and then you can go to Desmos to get the points that you actually are going to graph. Let's look at this one. It says +1, so my asymptote is y equals 1. I see that there's no negative, so I know that there's no flip. So our range, y is greater than 1. Domain, that's the easy part. Why don't you try this one on your own? Probably was too fast for you to actually click pause and try it on your own. This one moves down 2, so our asymptote is y equals -2. Which means our range is y something -2. There's no flip, so it's y is greater than -2, and our domain is all real numbers. Now, on all of these, after you find your asymptote, I would also take the time to dash that in, because then once you find your points in Desmos, having that asymptote line visually on your graph will help you to draw your graph in properly. All right, we're going to look at one more of these. I'm going to change this though. Let's make this y equals e to the x plus 2 plus 4. I just want you to see what these look like in Desmos. So take a moment and write that down on your paper. Y equals e raised to the x plus 2. Oop, I want to do -4, not +4. Sorry. Y equals e to the x plus 2 -4. If we go back to Desmos, clear this one out. Where's my mouse? Y equals e. You just use the e on your keyboard. It doesn't have to be a special button, just e. Desmos knows that by e you mean that special number. To raise e to an exponent, you need your caret button. Your caret button is above the 6, so you push Shift 6 to get up there. You also can click on this little keyboard thing, and then it has like this button that would allow you to raise it to an exponent. E to the x plus 2. I do need to put that x plus 2 in parentheses so that the plus 2 stays up in the exponent. And then -4. E graphs work the same. The plus 2 indicates left 2. The -4 indicates down 4. So as far as doing these problems for the domain, range, and asymptote, they're the same. The -4 tells us what our asymptote is going to do. Our asymptote is going to be at -4. So I can dash that in. Oops, not very accurate. The range. It's going to be y is either greater than or less than. I just want to show you in Desmos really quick. If there was like a -2 in front of the E, that would flip it. That would make it y is less than. I don't think we're going to deal with any where there's a negative here. That flips it in a different way. So you're still looking at the number in front. Is there a positive or negative in front? Here, there's no negative, so we know there's no flip. So it's going to be y is greater than -4. Our domain is still all real numbers. So really, before you graph, you're looking at x minus h plus k. You're looking here to get your asymptote. Your asymptote is basically y equals whatever that k value is. Then you're looking here. If it's negative, that means there's a flip, and that means your range is going to be y is less than your asymptote. If it's a positive number, there's no flip, and that means your range is going to be y is greater than your asymptote. And then just a quick review in case you had forgotten, to get points, you click the little wheel, the little settings wheel. Losing my mouse here. Click this little settings wheel that says edit list, and then you click convert to table. When it's an E function, your points are not going to be pretty. And that's okay. It's okay for your points to not be pretty. So record a couple of them, -2, -3, -1, that's -1.3, 0, 3.4. I think that's the only one that's going to fit. So then we'd go back here. I've got -2, -3, -1, -1.3. So you can definitely round those points a little bit. And then you're just estimating to the best of your ability. So -2, -3 is here. -1, -1.3 is like there-ish. And 0, 3.4 is there-ish. Connect these in a nice curve, and then to the left, get closer and closer to your asymptote, but don't cross it. On your assignment for today, worksheet 5, the first 6 problems are matching. You can use Desmos to help you if you need to, but honestly, I want you to look at the asymptote and whether or not there was a flip, and that will really help you to narrow it down. For 7 through 12, find the asymptote, the domain, and the range for all of them. So I'm going to write that. Numbers 7 through 12, find the domain, the range, and the asymptote. I would like you to fully graph 2 of them in numbers 1 through 10. Sorry, in 7 through 10. And 2 in numbers 11 through 12. So basically you're doing 11 and 12. For 7, 8, 9, and 10, I want you to pick 2 of them to fully graph. Any of the 2 of those 4 are fine.